Good morning, everyone. I'm Shota Olusegun. This morning, I want to continue with the time energy wave model. As you can see on the board, we have the time energy wave model where we stopped the last time. And here you could see that the energy wave travels like this, while the time wave travels like this. And so we have the expansion phase right here. Then we have contraction phase right here. We have the nuclear fusion here, which is the merging of deuterium to tritium that forms a bigger mass, helium. Then we have nuclear fission here, which is decaying of mass into singularity. Now, you still recollect that here is the singularity point. That is where the time and energy wave, where they collapse. This is the point where the collapse will emerge, and this is the point where the collapse will emerge. So we have this as the singularity point, singularity point. So now, one thing I want you to know is that entanglement, which is the entanglement of this big mass and this quantum mass, we have this as classical mass and this as quantum mass. The entanglement of the two is vertical, while the collapse of the wave itself will be horizontal. Will be horizontal like that, just as we have it. Another thing I want you to know is that if you look at this time energy wave, you see that whichever side you turn, you have inverse of the other side. So if you look from bottom up, you see that the bottom is an inverse of the top. And if you look from the left to the right, you see that the left is an inverse of the right. So that is the relationship. From here, we can say that the quantum realm is an inverse of the classical realm. And then the expansion is an inverse of contraction. So nuclear fusion is an inverse of nuclear fission. So now that that is being clarified, I want us to know that the integration from quantum realm travels vertically like this into the classical realm. And later on, in subsequent videos, I'm going to actually explain how we can use formula of everything to get the quantum mass and then the classical mass. So then I want you to know that the relationship, just like I said in the previous video, the relationship is inverse. The relationship of time relativistic scaling to energy is inverse to energy. So the relationship of time is inverse to energy relationship, and also the relationship of mass to time is inverse, and also the relationship of energy to mass is as well inverse. So that is why we have this expansion here, this suspension here. Now the mass is not at the bottom, it's not at the extreme bottom of the wave, it's being suspended, and so we have it right here, near close to the 0 point of the minima for quantum realm. And at the classical realm, we have it being suspended close to the 0 point of the maxima. So those are the things that we need to really understand. Then another thing that we need to understand here is there is what is known as speed difference factor. There is speed difference factor. Then I'm going to actually link this speed difference to Doppler effect. Doppler effect. I will link it to it. So now when you look at this, the realm, the quantum realm, is somehow contracted in such a way that the momentum of energy here at this realm, quantum realm here, is very intense. The momentum is intense here, while momentum here is relaxed. So the speed difference is one of the reasons that we have divergence in the unification of quantum mechanics to classical mechanics. We need to understand that. So this is the low energy state. We have this as low energy state. Low energy state. So the low energy state is as a result of the wide time scaling. So in relativistic, let me say in relativity of time to energy, when time is wide, then energy becomes low. I said that in the previous tutorial. So now we have the low energy state right here, and then we now see here that at this point, at the point of the collapse of waves, of time energy wave, then energy goes up, and so we have more intensity of energy at this point. High energy. Why time scaling is low here. So this is what we have here, is a phenomenon of energy momentum. And we have high entropy here. Energy momentum is high right here, and as we have the scaling of time to be so narrow, then the intensity of energy will be so high, and that is a phenomenon of energy momentum, and that is the same thing as entropy. So as time scales narrow, energy's intensity keep on increasing. So that is that. So this relationship is very, very essential for the next tutorial that we are going to explore, because in the next tutorial we're going to use formula of everything to get this particular mass and then this particular mass, and then we'll be able to see the asymmetric nature of the universe too by applying the formula. So we need to know that at quantum level there is asymmetric nature of universe, unlike what we are so conversant with, which is symmetric nature of wave pattern. We have polarization of wave, which means that before you can actually have wave, then it has to be symmetric at both sides, either up, down, left or right. It has to be symmetric. But from here, and from what I explained before, we see that there is speed difference factor, and because of that, the quantum realm is more contracted to classical realm to actualize or to really have that effect of speed difference. So we need to put that in consideration, and by the time we apply the formula of everything, we'll be able to see the essence of that asymmetric nature of the universe, which is the actual mass value for the quantum realm is the worth of the counterpart, which is the classical mass worth. But by the time it is being compressed by time energy wave model, you see that radiation that we have, the radiation effect will now be more intense and more enormous. And for that reason, the actual value of the quantum energy worth will be that of the uncompressed value. So that is that. I thank you all for your time. I want to implore you to like this particular video, then you subscribe to this channel so as to be notified for the subsequent videos. Then make sure you share the video. Thank you so much. God bless you. See you next time.